Welcome to Med Journal Club, where we break down the latest high-impact research that's changing clinical practice. Today, we're diving deep into a groundbreaking study that just dropped in the New England Journal of Medicine, the IMASOY trial. This is literally the first rigorous clinical trial ever conducted for bubonic plague treatment in human history. Yes, you heard that right. Plague is still killing people in 2025. And until this month, we had zero high-quality evidence for how to treat it effectively. So grab your coffee, hit that like button, and let's dissect this landmark study that's about to revolutionize plague management worldwide. Here's what blew my mind when I first read this paper. Plague affects 600 to 1,000 people globally every year, with 75% of cases occurring in Madagascar. This isn't some medieval disease we left behind. It's a high-consequence pathogen with genuine epidemic potential and even bioterrorism risk. But here's the shocking part. All current treatment guidelines are based on weak evidence. We're talking about recommendations built on animal studies and case reports, not a single randomized controlled trial. Think about that for a moment. Physicians worldwide have been treating plague based essentially on educated guesswork for decades. The existing treatments require Aminoglycoside-Ciprofloxacin or gentamicin, which means twice-daily injections, hospitalization, specialized monitoring, and costs that are literally 20 times higher than oral alternatives. In resource-limited settings like rural Madagascar, this creates impossible barriers to care. Ethics obviously prohibit placebo-controlled trials. You can't give someone with plague a sugar pill. So researchers had to design this as a non-inferiority trial to finally get some real evidence. Here's the million-dollar question the IMASOY investigators tackled. Is oral ciprofloxacin monotherapy non-inferior to the current standard of sequential aminoglycoside-ciprofloxacin combination therapy for bubonic plague? This might sound like a simple comparison, but the implications are enormous. If successful, this could transform plague treatment from a hospital-based, injection-dependent nightmare into a simple oral therapy that patients can take at home. The IMASOY team designed a multi-center, open-label, randomized, non-inferiority trial across 47 health centers in 12 districts throughout Madagascar. They set their non-inferiority margin at 15 percentage points, meaning ciprofloxacin had to be no more than 15% worse than the combination therapy to be considered acceptable. They recruited 450 participants with clinically suspected bubonic plague, requiring fever, presence of buboes, and travel to plague-endemic areas. What makes this study remarkable is the sheer logistical challenge. Imagine trying to conduct a randomized trial in remote villages during unpredictable plague outbreaks. The enrolled patients perfectly represent the typical plague demographic in Madagascar. Median age of 14 years, 53% male, with 92% alert on presentation, though 16% were vomiting and all were febrile. Here's what made this study design brilliant. They randomized patients 1-to-1 to either oral ciprofloxacin 500 milligrams twice daily for 10 days or the current standard, aminoglycoside for 3 days, followed by ciprofloxacin for 7 days. Of note, they had to switch from streptomycin to gentamicin mid-study due to drug availability, a real-world challenge that actually strengthens the external validity of their findings. All patients were hospitalized for the first 3 days and then followed daily by community health workers, which likely improved adherence compared to routine practice. The primary endpoint was treatment failure at day 11, defined as a composite of death, persistent fever, secondary pneumonic plague, or need for alternative treatment. These were analyzed as secondary endpoints as well, and adverse events were also noted. Here are the results that are going to change everything. Both treatments were incredibly effective, with roughly 90% success rates overall. Treatment failure occurred in 9% of the ciprofloxacin group versus 8.1% of the combination group. A difference of just 0.9 percentage points with a 95% confidence interval of -6.0 to +7.8. That upper bound of 7.8% is well below their 15% non-inferiority margin, definitively proving non-inferiority. But here's the kicker. The case fatality rate among trial participants was only 4%, compared to 23% in non-trial patients in the same districts during the study period. This suggests that both regimens, when properly implemented, are dramatically more effective than current routine practice. The secondary outcomes were virtually identical: similar mortality rates, same rates of secondary pneumonic plague. The adverse event profiles were comparable too, adding to the evidence supporting non-inferiority of the oral monotherapy regimen. Let me be clear about why this study is so important. This is the first adequately powered randomized controlled trial for plague treatment in human history. The investigators enrolled 61% of all confirmed plague cases in their participating districts, making this an incredibly representative sample. They conducted this in real-world field conditions across diverse healthcare settings, from peripheral dispensaries to regional hospitals, with local doctors and nurses managing patients according to national guidelines. The robust methodology included appropriate non-inferiority design with well-justified margin, and the clinical relevance addresses an urgent global health need that's been neglected for far too long. No study is perfect, and IMASOY has important limitations we need to discuss. The open-label design was unavoidable due to different administration routes, but this creates potential for performance and detection bias. More concerning were the measurement challenges with bubo size assessment, which proved unreliable in validation exercises. The mid-trial switch from streptomycin to gentamicin, while handled appropriately, still represents a protocol modification. Geographic limitation to Madagascar may affect generalizability to other plague-endemic regions. And the day 11 endpoint might miss late complications, though this follows established clinical practice patterns. The clinical impact of this study cannot be overstated. First, it validates oral ciprofloxacin as a first-line treatment for bubonic plague, which simplifies treatment in resource-limited settings where most plague occurs. The economic implications are staggering. We're talking about a 20-fold cost reduction plus eliminated hospitalization requirements. This strengthens recent WHO and CDC recommendations that were previously based on limited evidence. Looking forward, these findings may inform treatment protocols for pneumonic plague and could revolutionize outbreak preparedness in non-endemic countries. For pediatric populations where fluoroquinolones have been traditionally avoided, this provides crucial safety and efficacy data. Here's my bottom line. Oral ciprofloxacin monotherapy is non-inferior to combination Aminoglycoside-Ciprofloxacin therapy for bubonic plague, offering a simpler, safer, and dramatically more cost-effective approach. This isn't just an academic exercise. This study will save lives by making effective plague treatment accessible in resource-limited settings where it's needed most. Two critical questions for discussion. How should these findings influence plague preparedness strategies in non-endemic countries that might face bioterrorism threats? And what are the implications for treating plague in pediatric populations where fluoroquinolones have traditionally been contraindicated? Drop your thoughts in the comments below. I'm genuinely curious about how this might change practice in your institution. Don't forget to like and subscribe for more evidence-based medicine content, and I'll see you in the next video.